going to continue our studies today with more compound sentences. And we're going to look at the inequalities. So let's just review a conjunction here. Remember, a conjunction is the word and. So our answer that we're looking for has to have two qualities. In this case, it has to be greater than or equal to -4, and at the same time, it has to be less than 8. So if we were to graph this on the number line, first we would go to our two extremes and circle them. In this case, it's a -4 and a +8. The -4 would get colored in because we're allowed to pick -4, and I'm just going to erase that dot right there, make it a little better because it doesn't look and remember, with a conjunction, we conjoin the two because our answer can be anywhere in between. And there's a conjunction. A disjunction means or. So we can go one way or the other. We have our choice. So in this case, we have 8 and 10. Now remember, they're not equal, so we can't pick 8, we can't pick 10. We can pick any number less than 8 and win this game, or we can pick any number greater than 10 and win this game. So this is a pretty easy game to win. There's very few ways we're going to lose. In fact, if we had to write a conjunction on how we would lose on these numbers right here. That means we would lose if we picked 8, any number greater than or equal to 8, but the number has to be less than or equal to 10. So this is the conjunction on how we would lose this game. Pretty cool. So I'd like you to pause here, and this is one thing that I've found year after year students have a lot of difficulty with, and it is how to write a conjunction properly. So what we have here, this is called a template. General form of a conjunction written algebraically would look like this. Now, I'm saying general because this could change. Remember, this could have a less than sign and this could have a less than sign, or one could be less than and the other not. But the general form is we have our endpoints, and then the value we're looking for is in between the endpoints. So please, please, please get that straight. I see a lot of times this is written really weird. In fact, I don't even want to write how some kids write it. I want you to learn the correct way, and this is the correct way. There seems to never be a general form of a disjunction written algebraically by students, and once again, remember, these could have less than or equal to, greater than or equal to. You can have one be and the other not. So this is the general form. We have one extreme or we have the other extreme. So now we're going to go a little backwards today. Today we're going to give you the graphs and you have to figure out whether it's a conjunction or a disjunction. So for example, 1 here, I want to get to the fact that a conjunction means I am joining 2 points. And I am indeed joining 2 points here. All right, so I'm going to come back here. I'm actually going to grab this template because I've realized that this is a conjunction. I'm joining 2 points. All right, so what points am I joining? There's my 6, 7, 8, -8. and my highest number is 2. Now, since they're both open circles, I do not put equal signs down here. So there, I just wrote my first conjunction. My x value is somewhere in between -8 and +2. All right, down here, am I joining 2 points together? No, in fact, they seem to be running away from each other. Going this way, going that way. So that's an or statement. So I would come over here, I would grab my template for a disjunction. All right, so this is a -1, and this is a +5, but notice how it's colored in. That means I have to add an equal sign here. So this game says if I pick an x value less than -1, or if I pick an x value greater than or equal to 5, I'm going to win. Example 3. Consider the compound inequality. Okay, there's the word compound. When I see the word compound, immediately I've got to know this is either a disjunction or a conjunction. It's part of math. I got to discern. I got to make up my mind. So let's read. Wow, this looks like nothing we've seen before, but I'm not going to let that disturb me because there's a big important word sticking right there. And. Well, that just made my life easier. It's got to be a conjunction because and means conjunction, to conjoin. Now, how do we solve this? Well, I see one equation here and I see another equation there. Well, you know what? I know how to solve equations, so I guess I'm going to start by solving equations. So I'm going to take this first one right here. 6x plus 1 greater than or equal to 4. 6x. If I inverse operation that to the other side, it becomes 3. Inverse operation multiplication. Careful here. This answer is 1/2, not 2. All right, I'm going to go and solve the other side. -2x plus 8 greater than -12. I'm going to inverse that 8 operation, which will bring that to -20. -2x. I'm going to divide by -2 both sides. Oh, that's right. I'm dividing by a -2. I'm dividing by a negative. So that means signs are going to be a changing. It's going to go to x. This greater than is going to go to a less than. -20 divided by -2 makes it 10. Now, we already decided it was an and, a conjunction. So I'm going to come back here and I'm going to grab my template for how I write a conjunction, bring it over here, and make the necessary arrangements. Okay, well, I know that I take my numbers and I put them in. Lower number on the left, higher number on the right. This is a less than, so it stays less than. But what's going on over here? If I rewrote this, 1/2. Oh, x is greater than or equal to, so I got to put an equal to sign in there. So that's what I have as my answer. Well, as usual, I want to check because what is this saying after all? Well, this is saying that if I pick an x in between 1/2 and 10, it's going to work in this equation and this equation. So what's an easy number between 1/2 and 10? 1. So I'll put 1 in there. 6 plus 1 greater than or equal to 4. Yes, I come up with a true statement. Halfway there. Now I'm going to check 1 on this side. Negative 2 plus 8 greater than negative 12. That becomes 6 greater than negative 12. Another true statement. So there, we've got the right ones right here. This is my answer. Okay, guys, we got some really cool ones to work on tomorrow. Those are going to be fun. See you then.